Earth's magnetic field has been weakening at an accelerating rate, and 2025 satellite data reveals concerning changes in our planet's invisible protective shield. Scientists monitoring the magnetic field have documented a 15% decline over the past 200 years, with the rate of weakening tripling since 1980. This isn't the gradual, uniform decline researchers initially expected. Instead, specific regions are experiencing dramatic drops in magnetic field strength that have prompted intensified monitoring efforts worldwide. The South Atlantic Anomaly represents the most significant area of concern, stretching from Brazil to South Africa. This region has lost substantial magnetic field strength over the past 50 years, creating what scientists describe as a magnetic weak spot where charged particles from space can penetrate deeper into Earth's atmosphere. Satellites passing through this area regularly experience computer glitches and electronic failures when they encounter the compromised magnetic protection. The European Space Agency has documented magnetic field strength dropping significantly in this region, representing some of the fastest rates of magnetic field decline on record. Aircraft flying over regions with weakened magnetic fields now face increased radiation exposure, forcing airlines to adjust flight paths and limit crew flight hours to protect pilots and passengers. The aviation industry has implemented new protocols for routes that pass through areas where magnetic protection has diminished substantially. Flight crews working these routes receive enhanced radiation monitoring and modified scheduling to minimize their exposure to cosmic radiation that would normally be blocked by a stronger magnetic field. The technology systems across the globe face mounting challenges from magnetic field fluctuations. GPS satellites lose accuracy when operating in regions with compromised magnetic protection, leading to navigation errors that affect everything from smartphone mapping applications to precision agriculture systems. Power grids experience more frequent disruptions as geomagnetic storms become more intense without adequate magnetic shielding. Electrical infrastructure in affected areas suffers voltage fluctuations and transformer failures at rates significantly higher than regions with normal magnetic field strength. Communication networks encounter severe challenges during periods of magnetic field instability. Radio signals that normally bounce off the ionosphere get scattered and distorted when magnetic field irregularities disrupt the upper atmosphere's electromagnetic properties. Emergency communication systems for aviation and maritime operations experience blackouts during geomagnetic events that would have been manageable with stronger magnetic protection. Internet infrastructure relies on undersea cables that can suffer induced electrical currents from magnetic field fluctuations, causing widespread connectivity disruptions. The health implications of magnetic field weakening have become a growing concern for researchers studying radiation exposure patterns. People living in areas with significantly reduced magnetic field strength show elevated levels of cosmic radiation exposure, particularly airline crew members and frequent flyers who spend extended periods at high altitudes. The increased radiation exposure correlates with higher rates of certain health issues, though long-term implications continue to be studied through ongoing population health surveys. Animal species that depend on magnetic navigation for survival are already showing signs of distress from magnetic field changes. Sea turtles, which use magnetic field patterns to navigate across ocean basins during migrations, have been found stranded on beaches far from their normal routes. Migrating birds show increased disorientation and navigation errors, with some species arriving at breeding grounds weeks later than normal or failing to reach their destinations entirely. Whales and dolphins that rely on magnetic navigation for deep ocean travel have been stranding themselves more frequently in areas where magnetic field anomalies disrupt their natural compass systems. The disruption extends to smaller animals as well. Bees rely on magnetic field detection for navigation between their hives and food sources. Beekeepers in regions with significant magnetic field weakening report decreased honey production and increased colony collapse rates as bees struggle to navigate efficiently. Even bacteria that use magnetic particles for orientation show altered behavior patterns in areas where the magnetic field has weakened substantially. Scientists have deployed extensive monitoring networks to track magnetic field changes in real time. The European Space Agency's Swarm mission uses 3 satellites to create detailed maps of magnetic field variations across the globe. Ground-based magnetometers stationed at over 130 locations worldwide provide continuous monitoring of magnetic field fluctuations. This monitoring network can detect small magnetic field changes and provides early warning systems for space weather events that could damage satellites or disrupt power grids. Protective measures are being developed to shield critical infrastructure from magnetic field-related disruptions. Satellite manufacturers now install enhanced radiation shielding and backup systems specifically designed to function during magnetic field anomalies. Power grid operators are implementing surge protection systems and backup transformers in regions identified as high risk for geomagnetic disruption. Emergency communication networks are being hardened with protective shielding and redundant systems that can maintain operation during severe magnetic storms. The research community has established international cooperation programs to study magnetic field changes and develop coordinated response strategies. Scientists share real-time magnetic field data across national boundaries to create comprehensive global monitoring systems. Research teams collaborate on computer models that simulate magnetic field behavior and predict future changes. Emergency management agencies are developing response plans for scenarios involving severe magnetic field disruption. Computer models predicting future magnetic field behavior suggest that current trends could lead to significant changes in magnetic protection over the coming decades. The mathematical projections become increasingly uncertain beyond shorter timeframes because magnetic field behavior involves complex interactions between Earth's molten iron core and its rotation that scientists don't fully understand. These uncertainties make it difficult to predict exactly when and how magnetic field changes might affect different regions of the planet.